Okay, now good evening to one and all. My name is Ken Lam. I'm from the local community engagement office. Welcome to NTU, one of the top 15 most beautiful campuses in the world. Just a quick check. How many of you are visiting NTU for the first time? So actually, there are not many. Last talk, we talked about cryptocurrency. There were like more than half of them first time to NTU. So I would urge that besides attending lecture, also try to spend some time exploring NTU because we have been transformed to a mini city. There are quite a number of nice, iconic buildings as well. You can do it other time if you like to because, as you know, NTU is a public premise. Anybody can come and visit. So long as you don't interrupt the learning and teaching, I think that's fine. Okay. Now, the flow for today's talk will be this. We will have talk by our speaker, followed by a panel discussion. And of course, we will leave about 25-30 minutes for you to ask questions. All right? Now, a little bit about this talk. Now, this public lecture, or we call it Did You Know Monday Talk Series, is one of the many initiatives we have rolled out to help Singaporeans appreciate research and its benefits. This is our 12th edition. We actually started in July 2017. So we have come a full circle, and we intend to continue this. Hope that many Singaporeans will benefit from this talk. Now today we are very honored to have invited our one of the professors from the School of Mechanical and Aerospace Engineering, Professor Ang Wee Teck. Let me give you a little bit of his background. Now, Prof. Ang received his PhD degree in robotics from Robotics Institute, Carnegie Mellon University, USA in 2004. He also obtained his master's and bachelor degree in mechanical engineering from NTU in 1999 and 1997, respectively. Now, Prof. Ang is currently an associate professor at the Mechanical and Aerospace Engineering at NTU, and concurrently the acting executive director of the Rehabilitation Research Institute of Singapore, a joint collaboration by NTU, A-Star, and National Healthcare Group. Now, Prof. Ang's research focuses on this robotics technology, how to actually apply this to medical applications. And let me just read out some of this as well. So these biomedical applications include surgery, cell, micro manipulation, rehabilitation, and assistive technology. His work has been well-funded, published and cited, and has also resulted in several inventions licensed to the industry as well as spin-off companies. Now, without further ado, let's put our hands together to welcome our speaker, Professor Ang Wee Teck. The clip on, can we on it?
Can you hear me? Okay, right? Is it too loud? Okay. Okay, all right, thanks. Okay, thanks Ken Lam for the introduction. So today I'm going to tell you a few things about robots. So this title is proposed by me. So I thought this is a good way to share what robotics is all about. So people that are predicting the future, they say that robots are going to take over half of human job that is currently today done by human in about 20 years. So that make a lot of people fearful for what robotics is all about. So what are we fearful about? So Elon Musk, I don't know whether you guys heard of him. He's the founder of SpaceX and then the company Tesla. So multi-billionaire. So he says this thing: robots are going to do everything better than humans in the future. So when people as rich as him, as prominent as him, say something like that, that scares off a lot of people. right? So when you do not understand the technology, when you do not understand how good robots are, it makes you fearful, right? That's a natural instinct. So do you feel fearful when Malaysia say that they're going to overtake Singapore? They just say that, right? Yeah, so if we know how good Malaysians are, perhaps we shouldn't be that fearful, right? But the thing here is that if you understand robotic technology, maybe you wouldn't be that fearful anymore. On the flip side, this person here, Rodney Brooks, he's a former director of MIT AI Lab, a very prominent figure in the world. So he's founded 2 very successful robotic startups. He says that this is BS. It's not true. It's not going to happen, right? So it's one end, entrepreneur selling technology. On the other hand, people building robots say the directly opposite things. So today, I'm going to lead you through this journey here. I'm going to tell you about robotics technology, the bolts and nuts of robotic technology and AI, and explain it in layman terms. And hopefully you can appreciate the state of the art of robotics technology now. And then I talk about robotics for Singapore. Why Singapore has embarked into the journey for National Robotics Program. Why is robotics important for Singapore? What is the strategy? What have we done? What are the things that we could have done better in our NRP, National Robotics Program? Having said that, then I zoom into the stolen jobs, the jobs that robots are stealing from us, Singaporeans. And then from what we have discussed, then we zoom in to say that what would be the impact of these stolen jobs, right, from robots. And then, of course, then I will have this panel discussion with my 2 dear colleagues here. And then the last will be Q&A. So, right, let's start. So, a half an hour tutorial on robotics technology, right? Robotics for the dummies. So first thing first, let's see where robot starts. First is the demand for helpful machines. We need that, and then we have industrial automation, right? So we build machines, and then we lead to industrial automation. Then as we progress, we think that this hard manufacturing is not good enough. We need flexible manufacturing. And then there we go. We have the robots building cars. So that's in earlier years. And then as we go on, the spin-off from industrial robots will be service robots. So the one type of service robots will be field robots. Field robots constitute of robots that go underwater, on land, on the sky, and to the space. Right? So these are we call the field robots. Service robots also mean medical robots. Anything that's outside of the manufacturing floor, we say service robots. So medical robots, we have robots for surgery, we have robots to do rehabilitation for, say, stroke patients, right? And we also have social and domestic robots. So for example, we have robots for social interaction, for the elderly, for dementia, more therapeutic kind of interaction. We also have robots for entertainment, robots for education, so more social. And then the domestic, we have things that are robots for cleaning, sweeping your floor, for delivery, and robots for cooking. Right? These are all coming into our lives now. So as this thing progresses, the merge of service robots and industrial robots will come out of this breed of robots called collaborative robots, in short, cobots. It's a buzzword in the past few years. I'm not sure whether you heard of this word, cobot. So what is a cobot? Cobot are robots that are used mainly for industrial application, but it allows people to work alongside with the robot. In the olden days, the industrial robots, they are heavy, they are powerful, so they're always caged up. So that people are not allowed to go into the boundary of the robots for safety purposes. Cobot, on the other hand, is designed to work alongside human beings, right? So there are several features that allow this thing to do so. Let's take a look at 2 robots here. Let me bring us to YouTube.
Think adding automation to your production line limits you to high cost, high volume, caged robots. Think automation requires specialized robots programmed by highly trained engineers. Well, think again. Baxter breaks out from the protective cages that contain many manufacturing robots, allowing people and robots to work side by side, doing what each does best. From machine tending to line loading to packing and unpacking, Baxter has the flexibility to be deployed and redeployed on tasks with minimal setup or integration cost. Whether there's increased customer demand or the introduction of a new product, Baxter helps you create a collaborative workforce, one with increased productivity and efficiency. Think about getting all this for a base price of $25,000. That translates into an ROI of months, not years. Now think about what Baxter could add to your plan. Rethink manufacturing. Rethink what's next. Rethink robotics.
We better go back first. If not, this thing will rerun again. Right, so that's, am I still on? So that's one type of collaborative robot. So that one, you see, right, it allows the robot to work alongside with human being. So the main design that is that the joint is no longer hard. Right, hard means that when it hits someone, the person, the full force of the power will get transmitted from the robot to the person. But the joints of cobots are usually variable. That means the joint can become soft the moment that it touches a human being. So that when humans get into contact with the robot is no longer harmful. All right, so that's one big characteristic of a cobot. So there's another type of cobot, no arms.
On the ranking of things to worry about, Skynet coming and taking over doesn't even rank in the top 10. It distracts attention from the more urgent things, like, for example, what's going to happen to jobs.
For a glimpse into the future, consider one of the largest companies on the planet, Amazon.
Amazon has tremendous scale. We have fulfillment centers that are as large as 1.25 million square feet. That's like 23 football fields. And in it, we'll have just millions of products.
To deal with that scale, Amazon has built an army of robots.
Like a marching army of ants that can constantly change its goals based on the situation at hand, right? So our robotics are very adaptive and reactive in order to extend human capability to allow for more efficiencies within our own buildings.
And there's plenty more where those came from. Every day, this facility in Boston graduates a new batch of machines.
You get the idea? So in fact, Amazon did not build Kiva system. They purchased from a startup company $775 million. So that they can take the technology off the market, so that they are the only people that can use this technology. So you can see, robot work alongside with human being. So that's cobots. So there's another track of development that's also from the human desire to replicate nature. So Leonardo da Vinci building a robot-like thing. Honda was the first one to build a successful Asmo. And then we have our own NTU invention here, Nadine, which is a humanoid robot aimed for being a receptionist. So we also try to mimic nature, flying machine, ants, big dog by Boston Dynamics. Right, so this would be the development of robots. The recent development, the latest one, is this thing called the bots. So no longer robot is in the physical form. So people think that bots is a software robot, all right, on the internet, a software system that are intelligent enough to chat with you, to do trade. trade bot, right? Trade bot can trade faster than any human trader, right? At a million times the speed of a human trader. So for very quick trading, people use trade bot. Service bot for shopping, for F&B. So these are all robots. So then you ask, what is the difference between automation and robotics? So in a traditional sense, this is fixed or hard automation, programmable automation, and then with cobot, right, we have flexible automation. On the other hand, this is industrial robot, this is collaborative robot, this is service robot, this is social robot. In fact, we call this thing robotics. In fact, this is the overlap. These are equivalent, and these are equivalent. And in this axis, if we add 3D printing, Internet of Things, big data, integrate them together, it's the whole concept of Industry 4.0. All right, so but this talk is not about Industry 4.0, but robotics is part of Industry 4.0. And how do we define a robot? Because now software can be a robot, right? A robot is a system which possesses an integrated ability of three things: perception, cognition, action. All right, you see, right? You get information in, right? Cognate means that you try to understand, right? You interpret the data, you make decision, and after that you take action. To do what? To interact and accomplish tasks in the real world or the virtual world. So then we have broadened the definition of what a robotic system is all about. As long as it possesses the three components here: perception, cognition, and action. In general, we can classify that as robotics technology. Right, so we zoom in a little bit more. Perception, sensors, how to use different sensors, computer vision, how to use sensing. The sensors means that hardware, sensing means the software. You make sense of the sensing data. Artificial intelligence, machine learning, genetic algorithm, fuzzy logics, all these things are the buzzword right now, AI, to make decisions. Planning, actuators, different types of smart mechanisms, smart materials. How do you do control and put everything together? How do you design the system to be robust? The interface between human and robot so that cobot can become possible. So these are the building blocks of robotics technology. Before we go on, I wish to spend some time to talk about artificial intelligence, AI. Right, this is basically that robots and AI is going to take over the world, right? So let's zoom in on what is AI. AI is, by definition, intelligence demonstrated by machines, as simple as that. But what exactly is it? So can I ask, intelligent, human intelligent, can I ask the audience, can I poll the audience, which one is a real woman? The left or the right? Who say left? Your left. Who say right? The right one is a real woman, the left one is not a real woman. Ask you again, what is the probability that you think that you are right? The left, what is the probability that you think that it's not a woman? How confident you are? 100%. 100%. On the right, how confident you are that this is a real woman? 100%. Yes, based on information, this is this. Ask you again, which one is a real woman? I ask again, how confident are you for this one to be not real? 100%. I ask again, how confident are you for this one to be not real? No, I asked real woman, right? I did not ask real people, right? So what is intelligence? So now, the first one, when I showed the first slide, you said you dare to bet your life on this thing that this is a real woman, right? But now I show you this slide with more information. Are you still as confident? So what is AI? Right? So intelligence is the ability to process, acquire information, and make good or relevant decision. Right? We say that this is perception, right? You take the thing in, right? Computer vision or whatever, the thing that you see. And then you perform cognition, your cognitive ability here. Right? You do data processing, and then you make a decision. So what is AI? Fundamentally, AI is about information, about data. That's why we talk about big data. Very importantly, big data, data analytic. With limited information, you make decision one way. With more information, you make decision in some other way. So AI, in fact, is all about data. You get garbage in, you get garbage out. We see more, all right? Artificial intelligence. Same thing here. It is the gist of artificial intelligence. Of course, we use programming technique to make machine intelligent. So in the gist of it, right, there are really two things that the machine is trying to do in terms of intelligence. The first thing here, to find relationship between the data points. All right. The second thing is that to categorize data points, or a combination of both. Remember the two pictures that I showed you? I asked you to categorize the data points. Which one is the real woman, right? Which one is real? Which one is not real? I give you some data there. You try to categorize them, real and not real, all right? But based on that, maybe not enough. I give you more information. Now you're able to link what you see, right? It's a cabaret show, so most likely these are transfer sites. These are not the real woman. So with that information, you link what you see, more data point, and link here, you impact what your decision is all about. So now, with that, right, you try to make decision based on the probability of relationship and classification. So the main gist of what AI is all about is to do exactly this thing. Of course, there are many techniques involved. Let's give some example here, all right? To find relationship between data points. Now, sales of ice cream increases with shark attacks. Make sense? Does it make sense? But now if I show you more data, the months of sales of ice cream peak around here. Number of shark attacks peak around here. More data, right? We go one level deeper. And now it's summer. They are linked by summer times. Right? Why? Because in summer, the number of people coming to the beach increases, and hence the sales of ice cream also increases. Right? In summer, the water is warmer, more sharks migrate to this part of the ocean, and hence more shark attacks. And now if you go one level deeper, you have the link. Right? So on the surface, two pieces of data means it doesn't mean anything, but if you dig deeper, and then you find the information, you find the link, and that you can make decision. Right? And now imagine this thing here. We have data points linked at the depth level of n. We go one level down, we find the link, right? It's summer. But now what do you mean to go 10 levels down? A combination of levels, and then before you can find a link. For example, you try to find the link between a type of genes and a certain type of cancer. There's so many parameters, so many levels down that you need to dig up the information. For human to discover, to have this different combination, it's going to take years. But machine can do it in a very quick pace. All right? If all the data are being organized correctly, if you collect the right data. So the first technique that I'm sharing today is that how do we find relationship between the data points and what does it mean? So the second thing that AI does is to categorize data points. So now I give you a one-dimensional data. I want you to classify short or tall. Right? I can use a 1 point, 145 cm. Anything above is tall. Anything equal or below is short. So, right? So a one-dimensional data, I'm separate by 1 point, which is 1.45. But now if it becomes more complex, and now we have two-dimensional data set, this cluster 1 and cluster 2. And with this data is more complex, right? It's a 2D kind of data. But we can separate by one line. Right? Anything above the line is cluster 1. Anything below the line is cluster 2. But we have noise as well, right? Because not all the data are very clean. There's some noise at the boundary here. Things are not too clear. All right? Hence, the probability. What's the probability of this thing belongs to cluster A or cluster 1? What's the probability of this thing belongs to cluster 2? Depending on where this thing is all about, the probability at the edge here probably is lower. The probability here belongs to cluster 2, probability will be higher. All right, so this is another way if you can, because the data coming to you, right, computer must make decision. For computer to make decision, you must transform this thing into numbers for computer to process. All right, so we present it, I visualize these numbers into graphs for me to easily explain to you what happened behind the scene. And now, if we have complex data, all right, now this feature here can no longer be separated. The two clusters here no longer be separated with a lower dimensional features. When we have one dimensional, we use a point, right? When you have 2D, we use a line. So your separator is always a lower dimension so that it's easy to handle. So in this view, maybe we can't do so easily, right? If we use line, we need to use many lines in order to separate them. So that maybe we add one more dimension of data, all right? We add height. If more information come in, suddenly the blue one is higher than the red one, and we use a plane to separate them. All right, with more information coming in, we can manipulate them, transform them into another domain, we can separate them, and then we have a good separation. So this is another technique that we can do to separate more complex data. So imagine now a case with data points of n dimensions, 25 parameters. One parameter is one dimension, right? How can you classify them into how many groups? So it becomes a complex problem, a mathematical problem, a programming problem for scientists like myself to solve, all right? So that if we can do so, then all the data that come in, we can group them into groups. We can classify them. So this is one of my research work. So the idea is this thing, because I work in rehabilitation, right? So we try to assess the patient undergoing rehab training automatically. So we need a therapist to look at the patient to judge whether the patient is doing it correctly or not. So with this one, we are tracking the movement of the person, 24-dimension data. So 24-dimension, all the movement, right? So we're talking about a bunch of data here. So this is normal movement. So when the patient lower the neck, means that it's doing compensation. You cannot reach out, so you move your neck. Then that is considered, we detect this thing using this absolute z-score. Right, a 24-dimensional thing, we use a lower dimension indicators to capture, right, which is only this parameter here. So we use a trained neural network to detect the phase difference, and then we can pull out the z-score to say that the patient is doing this part wrongly. Right, the next one you see that the hand is trembling, right? The trembling, something is wrong. All they are simulated, of course. Simulated. Then when this thing will capture again, this is not the usual movement. So with this technology, it makes it possible for the therapist to be assisted by a machine. So when the patient go home, the machine can judge whether the stroke patient is doing the exercise correctly or not, without having the human to be there, right? So these are machine intelligence. And this is what to classify the data points. You are doing it correctly or not. All right, let's come back again. We say, right, AI is about data processing and decision making. So there are many good techniques in data processing, machine learning, deep learning, neural network. So all these things are good techniques that can separate the points, link the points. But what's difficult for AI to do is to make decisions. The decisions are all programmed by the programmer. Right, like my work, right? So I can tell whether the patient is doing it correctly or not. But I can't tell how wrong it is and how to rectify it. So the decision making, how many types of decisions are there to be associated with a class, that need to be programmed by the person, need to be judged by the person. The more sophisticated we put the decision in, the AI can perform better. All right, so this is the Achilles heel of AI in the last part, to make decision. So now, if simple decisions or simple decisions rule to be made for AI, AI will do very well. AI excels. For example, AlphaGo, this thing rocked the world, right? Go players, Weiqi, world champion, beaten by a machine built by Alphabet, the parent company of Google, 3-0. So this Ke was saying that it's impossible. He can never be beaten by a machine. And he got beaten 3-0. Why this is possible? Because the rules of Weiqi or Go is really simple. So when the rules are simple, decision making can be programming. Of course, they use a method, right, to self-train AlphaGo. The machine can self-learn, but also based on simple rules. And then based on simple rules, it can search infinite possibilities faster than human being. That's why he wins. However, if the situation, the rules of the games are not so simple, then AI will fall short. Because human is still behind the decision making for when this thing is being classified, when this thing happens, what is the decision associated with this class or this link? So that is the problem here. And I'm going to introduce to you Hubo, the world champion humanoid robot, and to demonstrate how this point is true. In 2015, DARPA is the military research organization of US. So they organized this thing called the DARPA Robotics Challenge. So the idea is for the whole world to come along to build a humanoid robot to undergo a series of challenges. So many teams around the world participated, sent in their robots. Hubo ranked number 1, running man ranked number 2, and Chim from CMU, my alma mater. So they came in number 3. And doing us proud would be our colleague from Korea, KAIST, Korean Advanced Institute for Science and Technology. Our Korean colleague, besides winning Germany, they're also good in building robots. So they turned up to be the champion in that year. Let's see what they did. So the robot's supposed to get up the car, drive the car to the destination. So all these tasks are told to them, but the size of the car, what route to drive, are not told. So they got to make the decision to do the driving. Get out of the car, kneel down, not to pray, but it's easy to move. You're on wheels. All right, they're supposed to look for the door, look for the handle. Using computer vision, it's checking now and detect where is it, open, manipulation, and then go in. And then you must find the first task, all right, to find this red valve. Turn the wheel automatically, all right? They must find the task. The task given to them, but where is it, the height, the sequence not told to them. The robot must make decision on the spot. Find the right tool. Take a long time to decide. Pick the right one. Not sure why it does that. Regrip again. This is planning. They are doing planning now. So that you can grasp the thing correctly. Find the target. It's looking for the target now. Know the depth. Turn on the drill or the saw. And then cut out the circle. And see that the circle is really round. Rounder than any of us can do. All right, done. Next one. To pull the cord out from one socket. So it's looking for the right way to approach. It gets lost somewhat trying to find its way. Find the target task, raise to the height. This is, I think, 4 times the speed or something like that. Pull out the cord. The task here is really hard because the cord is flexible. This is manipulating a flexible, deformable object. This is really difficult. Adjust, try. Cannot because it's flexible. You got lucky. Push the thing in. Done. All right, easier to move. Obstacles, left or right. You can go the step on the left, obstacle to the right. Inside said, I don't care, just bash it through. Other groups say that they are cheating. They're supposed to take the other path to walk over. All right, coming to the end, push away the obstacle. Come to the stairs. See, this robot is designed to be no front and no back. It doesn't matter front and back. So it's doing planning now, adjusting itself, doing planning, how high, calculate the dynamics of how to approach the stairs. All right, and then go up. And once you've taken the first step, it knows the parameters. The rest are easier. And voila, it finishes. It's the only one in that year that accomplished everything. So that's why they won. 1 month after the competition was held, the magazine called Popular Science declared that the DARPA Robot Challenge was a bust, was no good at all. That is a wasting of time. So let's see why. Not too good, right? Not too good at all. You say that it's busted. That's 2015. That's what the best of the world can offer. Hubo, why Hubo won the competition? It's not because that Hubo, in terms of robotics engineering, was the best. Hubo won because of the Kai's team behind adopted the best strategy, right? I was there in Korea playing with Hubo, with Professor Oh, the team that built this thing. That day, they did a demo, the robot kept falling down. One of the sensors was our calibration, right? Keep falling down, cannot take even one step. So the technology is not that robust. And why they won? Because all the major decision making is all done by the team behind. The rule allows them to have, I think 100 bit per second kind of communication. They can send simple signal over to the robot to guide the robot to communicate. And the CMU team, the red robot that fell down, they spent 10 minutes looking for the door handle on that day because it was too bright. The vision algorithm was not tuned to that brightness. So the robot spent 10 minutes looking for the door handle. But Hubo was simple. The team behind it said that the door handle is there, go there. All right, so immediately the robot made a decision. The decision, remember, between the obstacles to bash through or to walk through, the team behind made the decision for the robot. It's too unsafe to walk through, let's just bash it through. So it was a strategy behind that won the day for them. Why? AI not enough. All right, no matter how good you are, it's the decision making behind that's the toughest. You cannot take care of infinite situations on the ground because of uncertainty, and hence you cannot program all the situations in. For that, right, human intervention is the best strategy. All right, so that's 2015. Let's fast forward a little bit to see that what the best can offer now, 2018. Boston Dynamics.
Here are some of the terrifying robots from Boston Dynamics. This is Atlas. Boston Dynamics calls Atlas the world's most dynamic humanoid robot, and from the looks of it, they're absolutely right. Atlas is a bipedal robot capable of running, jumping, doing backflips, and keeping its balance like no other bipedal bot we've seen before. Its control system coordinates the motion of its arms, torso, and legs, allowing it to perform human-like tasks and achieve whole body manipulation. Spot Mini is a dog-like robot that is small enough for domestic use. Its arm, which looks like a mini brontosaurus's head, can pick up and handle objects around the home. Spot Mini is 100% electrical, making it the quietest robot Boston Dynamics engineers have built to date. Handle gets around on 2 legs and 2 wheels. Handle is a very agile and high-strength robot. Its wheels allow for high speeds and quick movements. It has the ability to jump over and even use objects like a table as a platform or track as it glides on its wheels, maintaining its balance. Handle's grips are great for picking up heavy objects and moving them around. Handle uses its handles for balance as demonstrated here in this endpoint control demonstration. Big Dog was one of Boston Dynamics' first advanced terrain robots and was the first legged robot to venture outside the lab, taking on some real-world conditions. Big Dog was designed to perform well in different environments. It can carry up to 150 kilograms and can climb slopes up to 35 degrees. Big Dog was developed for the military, who passed on the rugged robot because it was too loud. Sand Flea is like a small RC car. Don't be fooled by its small stature though. Sand Flea can jump 10 meters into the air. It can literally leap onto the rooftop of a building, landing softly. Think of it as a high-end RC car. Which one is your favorite member of the Boston Dynamics family, and which one do you think is most likely to rise up and kill us all? Leave a comment on this video and make sure to check out CNET's What the Future show at Facebook Watch.
Don't worry, it's okay. I think it's okay. Is it too loud, the video? Don't worry, I don't think I have many more videos. All right. So you see that capability in terms of control has been enhanced. So definitely better than any of those robots that we've seen in 2015. But you see that it's amazing, right? A robot can do all these things, but all these are well-rehearsed tasks. The robot pick up something 10 times, perhaps a successful rate maybe less than half. All right, all these are for video production. It's not that robust yet. Boston Dynamics was purchased by Google 2013 at an undisclosed sum. Market say that probably around 800 million. But Alphabet, Google, sold it to SoftBank last year. It was said to be around 600 million at a loss of 200 million. Why? Because none of this technology can be monetized, right? How do you make money out of all these things? Because the thing is very good for show, right? Capability-wise, is marvelous. But to make it robust for the real world with AI behind is still a long way to go. So what it demonstrated is that we have done a very good control in terms of dynamics. We do the calculation well, and then we are there already, all right? So that's all. That's all I have to say about the capability of robotics. You have take a glimpse of what AI is all about and what robotic technology is all about. Next thing, we see that why Singapore needs robots. Singapore's needs, we have economic needs, we have societal needs. Economic needs to relieve labor crunch, to raise productivity. We all know these things. Societal needs to reduce import of foreign workers. All right, so we know the riot at Little India, right? Too many, when the workers come, we need to provide dorms, accommodation for them. Need to provide space for them to relieve entertainment. So that ever since we had the riot in Little India, they changed the mindset of the government. We stopped import of all these foreign workers. Okay, we kept it right away. So that's what? To relieve the strains on civil resources. You go on MRT, it's too congested, you complain. They lost vote, and then they did a U-turn. That's Singapore's need. So we see, right, Singapore's construction industry, 6% of the country's GDP, it consumes about more than 30% of the foreign workers. So what should Singapore do? Perhaps we can import highly skilled foreign talent. Meaning what? One guy to take over a few people's jobs. Right? No need too many, just one enough. Or maybe we say that there's not enough of such talent out there. Maybe we should use new construction methods. Some more. All right, maybe new construction method is needed. Maybe you can use precast concrete, maybe you can use 3D printing. Or maybe Singapore can go for robotics to solve the problem. Robotic worker, or we can use exoskeleton to make our worker even stronger. Right? Then Singapore started, yes, robotics perhaps is one of the ways that we can do this thing well. And we start from our needs, right? Economic needs and societal needs. And government say that, okay, now I will fund research and innovation for our industry to provide robotic solution. If the industry cannot find solution at this point in time, and let's just go to our highly ranked IHLs and research institution for the good researchers to provide the solutions. So when this thing is being built, right, we can license this thing, or we can create spin-off companies, become local SME to provide the solution. So remember what? Singapore's weakest link in the whole economy is what? Our SME. Unlike Switzerland, unlike Germany, the SME is very strong. Our SME only, what do? They only do trading with very low capability. Right? Maybe they can license this thing and make this local SME stronger, provide a solution to fulfill all these needs. So, and the government, on the other hand, maybe can fund adoption by lead demand agencies. These are the government agencies to say the hospital need manpower crunch, right? And let hospital, I give you hospital money to adopt locally produced solutions. SMEs say that yes, now government guarantee that I business when I invest in this thing, let me invest because SME is very low, very tight in cash flow. Say that now guarantee sales. So I invest, I license this thing, I invest, I build this thing, government pay for the bill, and after this thing is being tested and trial, they give me money and feedbacks, make this thing better, stronger. So if we pick the solutions correctly, that Singapore we have national needs, right? At the same time, all these needs are ahead of other countries. If we can do so, in time to come, we can export all these solutions. And then, in time to come, we level up our SME with capability that lead the world. We solve our national needs. It's a very good strategy, right? Don't you think so? It's very sound. This is the same thing that's what we do when we have needs, right? Our water needs. We created new water, we created water technology, and now our water technology leads the world, right? So this is the same template that we embark into this solution. In order for us to fulfill what we described here, the government come up with 3 strategies. The first one, develop class-leading technology and research capability. All right, research performers are all the IHLs, research institutions, and all the Singapore-based companies, right? We develop this thing, world-class technology. And then lead demand-driven. We use LTA to drive the use of autonomous car, hospital to drive the use of hospital logistic robots. Lead demand to drive the development of robotic solution. Technology, you custom build them into solutions, deliver here. And then they fund the industry to adopt the solutions, right? 3-pronged strategies. Develop technology, build technology into application, the solution to target the needs, and then we fund people to adopt. So this, again, is sound strategy. Then we set up the National Robotics Program, $450 million to start, led by EDB and A-STAR. The National R&D, Robotics R&D Program Office, NR2PO, is housed under A-STAR to lead this effort. At the same time, we have this automation support package, initially by Spring Singapore, and now becomes an Enterprise Singapore for people to adopt. So for NR2PO, they came out with the strategy for number 1 and number 2. Number 1 thing, they're trying to build robotics-specific, domain-specific R&D programs. EDB leading manufacturing and logistics. Right? How do you build solution? How do you adopt solution? These are the lead demand agency. And the public sector, LTA lead transport, NEA lead environment, MOH lead healthcare, and this one is Homeland Security and Defense lead security. So this in 2015, and in 2018, they added construction. This year, added construction. So this is lead demand, right? Government, I need this solution. You build, I pay. Then you come, then this thing will go upward spiral. Another one is the robotics enabling capabilities, technologies, R&D program. We are building deeper capabilities in all these fields. What is a robot, right? Robot is perception, cognition, action, mixed together into system. And also because it's cobot, so this thing become one of the big fields here. So everything under them. So now we recap again, right? So we have 3 strategies here, right? But there are gaps in why the strategy all very nice, right? As we see, right? Singapore government always very smart. The top level always very smart. Always come up with very good strategy. But the problem is always the devil in implementation. Our middle level people, government agencies, right, always fall short. Mostly our complaint, we complain the government. In fact, we should complain the agencies. But the government just take the blame for the agencies. So first thing first, adoption. There's a mismatch between problems and current state of robotics technology. So we see, I borrowed this slide from Wei Yun. So in 2017, make news headline. Koufu used robots to go around smart tray system. Today appear in the newspaper again because they are trying to list. Very good, right? 2017, a big fuss. 2018, Wei Yun staff go to Koufu again. It's parked there, abandoned. Wrong solution for the wrong problem. Why? For a solution to be adopted, right? You need the solution to solve the problem at least 80-90%, or at least 70-80%, right? Depending on how you draw the line. The thing can go around, but still, the technology is not good enough, right? So a lot of interference, not behaving well. But beside putting the tray, someone needs to clean the table, right? So it's not an end-to-end solution. How many of you own a vacuum cleaning robot at home? Not too many. Why? Why the rest you don't buy? Very cheap, $300. Now, why do I buy? Because it doesn't solve the entire problem. You still need to tidy up first. You need to collect all the things from the floor, turn on, the thing will go, right? The best is I sit there, press the thing will do everything for me, right? Yeah, that is your mate, right? So if you cannot do to the level, then why buy, right? Washing machine, press, finish, wash, finish already. But this one cannot, you must put everything properly, press the thing, then the thing goes, right? So that's why you're right, it's not fully adopted because it's not an end-to-end solution. Then again, right, we have a lead demand people, the agencies, very enthusiastic and say that let's embark into something. Sometimes they overshoot, they ask for too much, all right? Where people, they come to us and say that, okay, I want to have this robotic waste collector. You know the garbage truck, right? The people, they jump down from the truck to put the rubbish into the bin, right? They want this thing to be robotics. We have asked the Hubo team to work harder, right? The world technology is there. No, they want us to build this thing. Give us 2 years. 2 years, please build me this robot. It's not practical. AVA came to me to say that, Prof, I want to build a robot for me to chase after the wild boar and to shoot the tranquilizer. That's a weapon, no. Weapon. This one, you just go crazy in that 2 years. All the agencies just came to us, Prof, I need this robot. Please build me all these things. It's too much, right? We have to wait, now runway. Give me in 2 years. This thing must be deployed in 2 years. All right? That's what the lead demand agency thinks. Let's do this thing. And then sometimes they said, oh, it's just undershoot. There's no value at all, right? You use this robotic exercise coach to move. You can watch TV, right? Why do this thing? What's the value add? You see in the mall, there's robot go around, there's a tablet here to provide you with information. What's the problem? Information is all streamed to your mobile phone already. Why do you need to touch the robot chest? There's really no value add at all. Undershoot, overshoot, right? That happens. And then it's all KPI, right? Government people, all KPI, right? Must deploy, robotic technology, robotics, Azure robot program, we must deploy. So then the healthcare sector, they say that, okay, what's the problem? They buy a lot of robots from different manufacturers. All the robots with different communication protocol and different building come with different type of lifts. The lifts, some built by Schneider, some built by don't know what brand, all right? So then they say that, oh, how can different robots communicate with different lifts? If not, right, robots go and press button too hard already. You must do communication so that the door can open, can call for the lift. But the interface is too difficult. So then how do you solve the problem? You cannot do that, right? So then the too many robots, right? All the robots at night must go to park to the charging station. But all the interface, all different. All use up all the precious real estate there. So that we need so many charging stations to charge my different fleets of robots. Then the healthcare people say that, no, we had it, we cannot solve this problem. Without solving all these things, we cannot deploy. Let's just go for this robotic middleware framework for healthcare. So they say that they give out a contract of $30 million to say that let's solve this thing. Standardized platform. Standard platform, the plug are all the same, charging station all the same. All the communication protocol, all the same. This middleware thing to talk to different parties. Right? Then they created $30 million program that said, let's push forward so that this thing can be deployed. But the thing is this thing, right? The robotics world is moving very fast. Why we need to do this thing? Because there's no standards yet. Now all your charger, all USB, right? 5-6 years ago, Sony Ericsson, Samsung all come with different charger head, but now all USB. Why? Because 1 year ITU under United Nations say that all must standardize, all use USB. So very dangerously, it may make redundant when the international standards of robotics get established. We Singapore say that we have our own standard. But the thing is, right, all this thing, right, it's just a multi-purpose plug, right? Why is it so hard to make a multi-purpose plug for the time being until the standard has standardized? We spent $30 million to go and build all these things. Because why? We need to deploy immediately. So I keep advising against this thing. Please don't do that. We are spending our precious money on something that might get overrun when the international standards are there. And also, government come with the procurement model. They say that lead demand, right? I want this problem to be solved. I give out contracts. And the procurement, everybody bid for it. So when that thing happens, right, there's always a buy or build dilemma for the government agencies. Should I buy from ready solution or should I do capability building? Use our national people to build this thing so that we own the technology locally. So it's always easier to buy to fulfill the KPI. To build, it takes too long and may not be as good. But the flip side is that, so what if it's not as good, it's only equally good? We get to gain the capability of building that. And with all these things, right, remember the big thing that we must build, right, to own the technology so that we can something to export, right? They are not thinking of this thing because the eagerness to deploy. Always go for simple solution to build. KPI again. One day Singapore is going to get killed by the KPI thing. I'm a civil servant myself. I can criticize myself as well. Capability building, very important. All right, we're shortage of manpower. We don't have good training program now, and there's really no capability management strategy here. We always build, rebuild, build, rebuild. My own group, I can reuse my own technology, but the country has not. Singapore is way too small. Singapore should be operated like a company. Imagine Boston Dynamics, they make different robots. Every time you build a different robot, you need to restart from scratch again. That's what we are doing here. All right. Imagine NASA, whenever they send a spacecraft up there, they need to rebuild from the scratch again. That's what we are doing here. Government spending a lot of money to fund different research. The research spend the money there, funding this Italian professor to build this thing. The professor left Singapore, go back to Italy. We lost the entire capability. There's no value capture. Right? We have to do things differently. We've got to think like a company. All our robotics scientists put together in Singapore is not half as many as the one in Boston Dynamics. Right? That's how small we are. If we don't act like a company, don't behave like a company, there's no chance we can catch up. We do a lot of research. We publish a lot of papers. We're very good at publishing papers. That's all we can do, no? So how many companies are there? Right? How many big companies are there from Singapore? Because since we have a national robotics program, why don't we capitalize on this thing? So we came out with, we have been from the ground, we keep proposing of some idea. What if we have this toolbox? Government fund you to do project, right? You must return the capability back to the state. We have this national agency, National Robotics Office, to capture this capability. Then this capability can be reused. Like, can you imagine that Boston Dynamics, every time they build this thing, they must rebuild again? No, the capability built up, version 2, version 3. Ours is restart, restart, restart. It is time that we rethink of how we should approach this problem. Driving innovation, another gap. There's no provision for startup at all. The part of the sector with highest innovation is startup, but yet there's no provision for startup. I spoke with the chief of the National Robotics program. He said that not my issue. You talk to Enterprise Singapore. That time was Spring Singapore. I speak to Spring. Spring said not my problem also. The boss didn't say that we need to do all these things. So there's no provision as well. All right. There's only Singapore with a national robotics program without funding startups. You go and see the rest of the world, Japan, China, Taiwan, everybody have this thing to push startup, because startup is where the next unicorn that's going to come from, not from SMEs. All right, it's going to be startups. And then there's mismatch between government schemes, not good enough, poor investment ecosystem here. Time's running out, so I need to catch up a little bit. Stolen jobs. Let's go to the jobs now. What are the jobs that are being endangered by robots? Clerks, different types of clerks, right? Receptionists, information officer, bank teller, bank officers, vehicle drivers, manufacturing workers, logistic workers, fast food cooks, not your chef, not a celebrity chef, fast food cooks, retail salesperson and cashiers, telemarketers, security guards, construction workers, farmers. These are the jobs. Your occupation there? Feel scared now? Can it be replaced? Most likely not. I guess, if I guess correctly, most likely your occupation is not here. Let's review again. Singapore, societal needs, economic needs, societal needs. Societal needs, in fact, robots are creating new opportunities. If we don't have robotics opportunity to do this thing well, the company, the industry will fail, will ship out, will go to other country. Then we lose jobs. Or robots give us the capability, advanced manufacturing, Industry 4.0, give us some capability to retain our business, to attract new investment to come to Singapore. With that, we develop new industry, and the new capability can be established here. And that we create value and create jobs. So robots give us a new dimension. And the second thing here, robots transform jobs. If I guess correctly, 90% of you or even more are middle class. Middle class means what? I see some of the kids here. As a parent, do you want your children to be a security guard? That's my aspiration. That's my son to be a construction worker. Anyone want to do that? We are importing all these people because none of our people want to do that. And we don't want our children to do that as well. If you don't have a lot of education, you also don't want your children to go into that route, right? Because we are a first world country. We have aspiration. We want our children to be, next generation to be better. But now, if we think that now, instead of I hire more janitors to clean toilet, and now I have a fleet of robots that can clean toilet, but I hire many engineers to design and to service the robots. And we transform blue-collar work into white-collar jobs. And that you want, right? You want your children to be engineers that design the robot to wash the toilet, right? You don't want your children to be the one that wash the toilet, right? So that transforms the job nature for Singaporeans. And that's what we want. Isn't that good? So now, my crystal ball is going to be the last slide, second last slide. All right, robots are going to take over the jobs in the next 20 years. You should not be too worried, I think. Right? Why? Robots are not going to be better than humans in our normal activities of daily living in the next 20 years. Not as soon. I mean, you guys have been influenced by the sci-fi. Too good already. People that build robots knows that we are not at all too good now. Robots create new opportunities. Robots transform the nature of jobs to fulfill our aspirations. But you should not be completely not worried. Right? This is also true. All right? Because retraining will be needed for displaced workers to do the newly created jobs. And retraining will be needed as well. Even if you keep your job, you need to adapt to the working style with robots alongside with you. Right? All these are needed. So with this, the last thing that I want to leave to you is our dream in the robotics world. Right? Many years ago, we already said we want to build a fleet of robots to play against the winner of World Cup 2050. Just happened to be while watching the World Cup now, right? This is not made up, this is real, right? So we want to have a fleet of robots that can beat the human, right? So this is a grand challenge for the robotics community. So that's 2050, yeah? I'm not sure if we're going to do it or not, but let's see what can happen. All right, I leave the thing here, and we shall discuss what should we do. What should we do? Having this thing, and I should end here, and maybe I can invite my panelists to come aboard. Yeah, Wei Yun, come, please. Wei Yun is the head of department for robotics in I2R. Right, come, take a seat. And S.C. Chong, managing director of M Design Solution. So both are good friends of mine. He leads in the robotics sector for SIAA. So these are my people that I've known for many years. And the first question that I hope that they can share with you guys is that, what should you do? Right, I said don't be too scared, right? But I say that you must still be a little bit scared, right? So if you are a little bit scared, what should you do? I see you want to start? Yeah.
Hi, good evening, everybody. It's great to see so many people interested in the impact of robotics. I think I would like to share just a simple example. I think everybody take these technology innovations, the chain of technology pace as like a tsunami, right? So if you really look at tsunami, when you are at the shore, a building that is stationary, you're not doing anything, that is the one that has the huge impact by the tsunami. However, if you are a ship that is moving in the sea, the impact to you actually is not that great. Why? Because you're able to steer the ship, you're able to power the ship and put the direction of the ship in a way that will minimize the impact. So what I'm trying to say here is the following. Smartphone, computer, this is something also as disruptive as we could imagine. So Excel, PowerPoint, before this, people use technology, people use to have cloud to help them to prepare all this. So is it really a big deal? Do we really lose a lot of jobs for that? So today, it become a norm. All of us can handle all this technology. So I would say that for the robotic, it's the same situation. as what Prof. Ang has shared. They're coming, yes, indeed. But they're coming in a way not completely able to replace our daily job. So what we need to do is just be prepared, be into the system, understanding what is the application of them in what kind of cases. Just like the chatbot is talking about, easily replaced by the receptionist, but you enjoy working with the chatbot, you learn what is the technology, the capability. So it's these little bit pieces of knowledge, training, get involved, that you are able to work alongside with the robot. So that is what I see, right? Thank you.
Wayne, anything to add?
Yep. I think Prof. Ang also has given you a very good sharing, right? How the robots develop and what is the state of the robot. And I think he leave a very good conclusion. You should not be worried, and yet you should be worried. You should be worried if you are contented. You see, there's no way stopping the wave of robots coming in, but it will coming gradually, right? If you are contented with what you have and do not want to learn, then you should be worried. But if you have a desire, right? Robots don't have desire, but if you have desire to learn, keep on progressing, I don't think you have to be worried. Right? So these are the conclusions that I can give. So what can you be falling in category 1 or category 2?
Not sure if that elevates your fear. So can I take questions? Anyone would like to say any comments? Anything would like to ask anything at this point in time? Yes, please. There's a lady right at the top.
Hi, I would like to know that, in Japan, they've started teaching AI to lower level, like primary school and all that. So for Singapore, you mentioned that our efforts are more at the IHL level. So what do you think of how we can equip our students, young people, as far as, building our robotics capability is concerned? And secondly, where should a person start if he's interested in robotics? Is it more in data analytics or engineering in terms of building that knowledge? Thank you.
Maybe I answer first. So, what are our schools doing to equip our next generation to be robot ready, right? At the pre-university level or pre-tertiary level, not much. So it's remain as a hobby kind of activities. So a robotics club, student competition, and that's all about it. Because at that level, it's meant to be broad-based, right? So it starts from perhaps ITE and Polytechnic. So at that level, students start to touch a little bit of robotics and mechatronics. So that's as much as they can do. University, also not much. So we have engineering. Robotics, as I've shared just now, is an integrated technology. So you need the best level to teach robotics is in fact in the postgraduate level, because that you learn fundamental engineering, you learn fundamental computer science, and then you can do multidisciplinary work. So you'll be a little bit of stretch if you, without good fundamentals, you go into robotics teaching right away. So that is always a dilemma, right? So I know other countries have started to look at this thing quite differently. So it's robotics or mechatronics in some countries has become one discipline, so one engineering discipline, and now Singapore is still not there yet. Are we going to get there? I hope so. I've been personally, I've been pushing for our school to expand our robotics. We have this mechatronics stream. It was called mechatronics stream. I argued for many years. Mechatronics stream. Do you know what it does? You don't know, right? If I tell you robotics stream, you know what it does, right? But I mean, it's not fair. After my talk, you know more already. So the thing is, right, if we sell the kids that we have robotics stream, come to us, people get attracted. It's mechatronics stream is an old school kind of name. So it took my school a long time to adopt the idea, to go into that way. Again, right, you understand that from where we are right now, the higher ranking NTU, NUS get, the harder it is for us to steer, because we're very fearful of losing the ranking. What happened is that if we have mechatronics or robotic engineering there's no way to rank us anymore. And that you lose your ranking. So that is very real. So that, oh, now your KPI drop, right? So what should be done is that we want to adopt newer technology, and yet we are being held back by all this KPI thing and then world ranking. So this is very true. So as much as if I have magic wand to control, right, I would say that yes, we must systematically start this thing as early as from high school. Expose them. Perhaps for the physics module, you can start to introduce robots or whatever, or you have start a computing thing, right? And then systematically build up. Because in the future, it's all about robots. As of whether is it the software side or the hardware side, it all depends on inclination, right? You can only specialize in one field or maybe two, but you can't do too much. It's the same as whether you want to, if you are into business, right? Business also have use for AI, right? So why don't you do a business and AI, a joint degree, something like that. So we can think, it's time. It's time to answer your question, right? It's my dream as well. It's a thing for us to redesign the curriculum to make our students future-proof. But it takes time. It takes time. So I'm not the president, so take time. Yeah. Connect?
Yeah, I think just to add to Prof. Ang, I'm not sure how many of you are aware that in Singapore we have a RoboCup competition. And I think for the last few years I've been one of the participants or judge in one of the event, and quite happy to see that as young as primary school students participating in the competition. And they have also organized a competition in the region where we have students from Indonesia coming in. So they have different levels from primary school down to, they go by age, right? Different age category. And we have from primary school students who are giving robots from Lego, and they try to make a story, down to secondary school students who pick competitions, right? We talk about robot competing in RoboCup. So they also have robots that try to compete playing football, right? What are small robots? In order to encourage more and more children to study robotics, I think one way is that to get them interested in all these toys, right? Lego is a toy. Make them exposed to these toys from young so that they can get interest, and mention desire to see how it works, desire to build better solution, to do something that better than others, to compete, right? So I think that's one way to build up the interest. And of course, as Prof. mentioned, there's a hardware side and a software side. And unfortunately, robots need both together. As you've seen, many of the failures, the robot, you have good mechanical but don't have the brain. So how can we teach people from both sides, the mechanical side and the software side? And more importantly is that can this be exposed to more and more people? Because unfortunately today, some of the tools like Lego is not cheap, right? So we can have society, clubs, right, to promote the students coming in, but if you can make this as some extracurricular activities, encourage them to be exposed, and then eventually we can have more and more students being exposed to robotics solution. And hopefully when you go higher, including universities, then they can take up option for robotics. I think these are one of the ways that we can encourage. And hopefully once this being seen as useful, then we can have introduce comparative subjects, right, in the secondary level. But bear in mind, again, as mentioned, is the desire of students to try to learn these areas. And that desire will keep them going up, because eventually, after some time, the vacuum robots will be very good. Right? We have to build better robots. Yeah.
Before I go to SC, I asked the audience again the question that the point that we just raised. If you have children going to university now, would you encourage your children to do engineering? Or will you encourage them to do medicine, law, accountancy, business, which will make more money in the end? Right? Engineering, very tough, 4 years, very tough. Slot through the 4 years, make a little bit of money. Career path, very short. Must turn into manager. If you don't become manager, there's a cap about 40 years old. So would you, I mean, you ask yourself this question here, right? Many of our choices here are influenced by the parents. So always look at how much money you make after you have graduated. So unfortunately, engineering is not the most well-paid job. So then that's what I said just now in a very passing manner. What if we have this robotics module that you can partner with business? accountancy, medicine, right? So perhaps is you can still make money as a big doctor, right? But then you get to learn robots as well. So maybe that's an option. I mean, that's to add. Yeah, education. Yeah, sorry.
Yeah, well, probably coming from the commercial angle, I mean, from the industry. So I think with the end in mind, what at the end of the day is the kind of job that is going to be created in Singapore and the kind of job that will stay in Singapore. In fact, I just visited Thailand last week. Very interestingly, if you look at innovation, almost every country will give you the same template for innovation, right? Every country will say they will want to do the incubation, they will have grant from the agency to support innovation, engineering, hardware, all these are almost the same. This is primarily due to the internet world. From internet, all this information are readily available. So all the agencies who make the policy make the same thing. But what is really the difference? When we discuss in deeper detail, our agencies say, in Singapore, we fund a project that is proof of concept, we call, with 250,000. So when we ask our Thai counterpart, how much are you funding for your POC? Then when we make the conversion calculated, it's about 40,000 Sing dollar. So what does that mean? The difference is everybody in the region will have the same vision because of the innovation that will bring a better job for the next generation. So aspiration is the same. So how do you collaborate with these people? Ultimately, what kind of job will end up in Singapore? What kind of job will end up in Thailand? Though everybody want to have the same kind of job, like what Prof. Ang has just mentioned. Everybody want the children to be the engineer, to design the robot, to do that. So do you foresee that Singapore will have factory that produce millions of robots? How many of you believe that will happen in the next 10 years? We are producing millions of robots with factory. None, right? So what kind of robot technology will stay relevant to Singapore industry? Most likely will be what we call the end effector, the accessories. I give you one analogy, smartphone. Why the smartphone are able to come to this level of adoption and come to this level of usage? It's because the hardware of the smartphone is practically standardized. Then you can produce by the millions. When you produce by the millions, you can bring down the cost. Demand and supply is very simple. So where is the variation? The variation coming from the apps, correct? Remember the story how it was before that it was just press button, now it become a smartphone. Now, Singapore, I would say that in the industrial world, we have the role in the apps. Why? Because we are the earlier adopters for a lot of problems that we have. So if you think in that direction, so what is the part of the robotic technology that will be relevant for our workers in the future? You probably have to think in the same direction. I do not think, personally, at this point of time, for the next 10 years, we will be producing the complete robot. So if you ask your children to spend all the effort to understand, to learn all the complete technology about robotics, probably he'll be disappointed. That's my input.
I disagree. I disagree. anyhow. Okay, any other question from the audience? Yes, please, come. Pass the mic, please. You need the guy up there to turn on, I think.
Hello. Okay.
Yes, sir.
My name is Norman. I'm NTU alumni 2 decades ago. I would like to ask a few questions like this. In the earlier slide, you mentioned actually in 20 years, 50% of the job will be lost because of robot, right? I knew in Singapore we have the robotization will reduce the reliance on the foreign worker. But let's say if we look at the other countries, let's say like US and the rest, so can I confirm that actually the number of job created, which is highly skilled, will be much less than the job losses of the mostly low-end worker?
We can't say for sure, but the history has proven itself over and over again that it takes time to find the equilibrium. So when a revolution comes around, say when Henry Ford built cars, all the horse carriage rider all get out of job, right? So then, but a few years until today, you never talk about that anymore, right? So it takes time for the market to adjust itself. So this wave will come, but not all the jobs will be created at the same time when it is lost. But it will take some time for people to flow into the new industry which is created. So it gets harder for the people that are already in the 40s, in the 50s, they're already trained. That's why the government is spending so much effort on skills future. Because if you don't get to retrain, you cannot catch this wave. So that's a good reason. As I said many times, Singapore government, in fact, is very, very good in all these strategies.
Okay, two more related questions. You mentioned also just now 20 years, 50% job will be lost. But in terms of time frame, right, where is the tipping point? Is it closer to 20 years from now? Or is it progressive from now where the transition from the current job loss become taken over by a robot?
I think the first wave is not so much of job loss, is that jobs that no one wants to do. So then you put the robots there. So that's the first wave of transformation, not so much that it get completely lost. So I don't have the number to tell you when, is it sooner or later, but I think it's gradual. If I were to guess based on my own area of expertise, that means the robotics technology, I think it should be in the later part of robotics, in the later part of the 20 years time frame. As I said just now, right? If a solution is not solving the problem 80-90%, people wouldn't want to adopt. So we still have some way to go. So I think the growth would be towards the tail end rather than sooner. That's my guess.
Okay. Now the last question like this. Actually the last 2 or 3 decades, the manufacturing business moved to China because of cheaper cheaper labor. Then when China getting more expensive, the manufacturing moved to Vietnam or Africa and so on. With this robotization, right, will the manufacturing business actually back to the developed countries? Means the next country who rely on cheap labor may not even got the chance. So,
industry, you want to take that? Yeah. Industry? Yeah. Then I'll give my answer. I'll say I disagree again.
That's why we make it more interesting. But okay, I think your key point is actually talk about the cost. If you look at the manufacturing cost driver, what is driving the cost of a product? Typically, if you talk about, I think we need to split it into high volume production or versus mid-low volume production. Singapore, we still have manufacturing. We still have high mix, low volume, right? So high mix, low volume, because of that, then typically, if you're talking about high throughput production, bill of material, we call it, that means every part that you need to buy and produce is roughly about 80%. The value add is only about 20%, right? That is very typical high volume production. Whereas in a low volume production, we can be talking about, till the very extreme case, 35 to 40% is bill of material, and then your value add is the other portion. Now, if you look at this cost driver, where are the cost drivers coming from? Number one is the setting up of the production line, right? You need to set it up. Number two is material you buy, the operator that you have. So based on the percentage of that, you look at it, then you will know how much of that is relevant to your question that you asked, right? So if I need to make something back in Singapore with highly automated, with robotic and all this, what I need to do is to be sure when I set up something, it is run by again in the millions. So you need a certain uniformity of the product, homogeneous. That is where Singapore will still remain competitive for pharmacy, for drugs production, because it's highly, and we are also still competitive for the semiconductor business in the production, right? Because all this, you have high uniformity. Now, the other issue will be the precision required. As the technology moves, the chipset, all this becomes smaller and smaller. Then you need a steady hand, and you need robotic, which is the expert of Prof. Ang here, very precise. Then there is the next element building in because of highly miniaturization. So when you reach that level, yes, robotics will be very useful and extremely important. On top of it, with the AI, with a good design thinking behind that, that means now I design with robotic assembly in mind. What does it mean? That means when I assemble certain part, I don't flip it around anymore. I just stack it. I just keep adding, and just keep screwing and add it up. Now, in today's consideration, that will make your product very big, very heavy. But with new technology, with new processes, this can be adopted to the day when I can do assembly, design for robotic assembly. And then there's the day where I think definitely wherever you produce, it doesn't matter. With that program of the robotic, in fact, with that program, I can just ship material to any part of the world together with the robotic program of assembly. I can do it over there. And that is also the day where most likely the environment friendly recycle become easier because you have a program to assemble. The reverse of the program, you can do just disassembly. That will make the segregation of the part very much easy. So I think if you are able to move into that direction, yes, job will come back to. Right. I hope I have answered your question.
Yeah, I think so. Okay, thanks.
Under Obama, US have announced that they want the manufacturing to come back to the US. US, like Singapore, we have outsourced a lot of manufacturing to the point that a large part of the manufacturing is gone. So a lot of things are manufactured from overseas. So manufacturing is still very core to Singapore's economy, still about 20% of our GDP. So when I was in Shenzhen recently, and then there's an interview with the Shenzhen's mayor asking him that, because Shenzhen has moved on to be quite a rich city. So the question to the mayor was that, would Shenzhen abandon manufacturing? And the mayor was saying that, no, you will not abandon manufacturing because he cited two examples. You look at Hong Kong, look at Singapore. Hong Kong ship out all the manufacturing. Look at the state of the economy now. Singapore remain to invest a lot to transform manufacturing, the low end, into advanced manufacturing. What is advanced manufacturing? Is that parts that cannot be done elsewhere must come to Singapore to be manufactured. And that we can do a big premium because no one else can do it well except for me. So that attract the jobs and the money back. So although Shenzhen has become a very expensive city, but the mayor said that he will never abandon manufacturing, but he will transform manufacturing into the high end like Singapore, which robotics is an integral part. US is also playing the same strategy now. Right. So I think we're in good shape if we are investing in good technology and people have no choice but to come to us for the solution, and then we can charge a premium. Yes, please.
Oh, hi. Yeah. I hear Mr. Cheong mention something about that we can't do everything. So yeah, the full suite of robotics probably will never be done in Singapore. We need a large industrial base, even an innovative ecosystem for that. Now, to also sort of answer the question I think somebody asked earlier about, then what should our kids study? Maybe can you, to point it from another direction, might you be able to suggest in the entire robotic ecosystem, the scheme of things, what maybe Singapore might be able to focus on. Just like Rolls-Royce turbine jet engines, we only do the refurbishment here, for example, maybe repair the blades. But maybe how about robotics? What do you think Singapore might possibly anchor?
I would like to use what Prof. Ang has shared earlier. If you look at some of the very successful cases Singapore have done to transform our R&D effort into the real world, right? I think water is a very good example. Why? It's because everybody feel the same pain point. So either from R&D, from government, from the people, everybody feel that we need to solve the water problem, which is proven to be correct. Our neighbor just started again, want to negotiate the water again, right? So the point is, Singapore market typically is small. That is one of the biggest challenge we have. Anything we need to do, especially today, in the past, is okay. If I'm an MNC, I have a steady customer like a MNC, I have a government who give me the job, I employ somebody $2,000, then I just fulfill the order for $4,000, I earn between $2,000. That's how we build up most of the SME, right? But moving further down, this model cannot work anymore. Everybody is buying from Taobao, so it is really an open market, right? So you have to look at whatever you're doing to be able to reach the global market. So that's one. So the point is, water like this is something which even you do not yet has the market big enough, but because of the urgency, other factor coming in, that will make you be able to create the whole ecosystem. You have enough resources and power to make it happen. So I would say that for Singapore, some of the thing that is up and coming is really manpower constraint. In fact, just also share with you, one of the other example which I just visited my friend in AVA 3 to 4 weeks ago, he's talking about high-tech farming, which in the past, everybody write off high-tech farming for Singapore. Number one, electricity is very high here, cost, right? Property rental is very high here. So why would high-tech farming be relevant for Singapore? Now, the difference is, there are other areas that we did not notice. Number one, a vegetable from growing until the level that is put on the table, actually there are 60% wastage. 35% is wasted from the point you produce until you reach your giant, right? Because of the time. Another 25% is gone because of the sorting, because of whatever reason. So 40% of the food actually on your table being cooked is only 40, is being produced is only 40%. Now that is the current landscape. Now the technology has evolved in the high-tech farming to such a level that because of the IoT, because of the monitoring and all this, they know exactly what is the wavelength of the light to be able to good for certain growth of certain vegetable. They know exactly what is the amount of nutrition to optimize for each plant. They are able also to time how long you need to produce for the vegetable. What does it mean? That means you will drive from a supplier market to a demand market. That means now I can reverse the whole system to say that I want to order to have this vegetable in 10 days' time, then the vegetable will be just like how we handle the mass manufacturing today. That I will start producing based on the lead time. Now, this is one of the examples I want to give to say that we have to look for such opportunity for Singapore, where we are the one that is in the space that has the desperation to require to solve this problem. And because of that, actually in the high-tech farming, Singapore is getting closer to really the world class, the leader. Because the rest of the world, they don't have this pain point. But they will come later. Example, why? China, ASEAN, farmer is getting old. average is above 65 to 70 years old. Nobody want to become farmer. But they still continue for the next 10 years. Whereas for us, actually this is the immediate pain point. So because of that, that kind of driven innovation, that kind of technology innovation will be faster than the rest. So I can't answer your question directly because otherwise.
Can I ask Wei Yun to address this thing? Can I ask you to comment on thing that I disagree with? He said that, that Singapore shouldn't build the entire robotic solution. We could focus on parts or what I call components. So
Okay.
can you address that?
Yeah, maybe I can. I think this probably I could help to address some of the questions as well.
Yeah.
So if you look at, for example, we say that our labor cost is expensive, but compared to US, we are still not that expensive, right? But why planes are built in US? Boeing, for example, built most of the planes in US. Why? Workers are expensive, yet they can build planes. Why? Because the cost of planes is very high. The parts to build, just to fabricate some of the parts, maybe can import. Even some of the wirings are actually done by human in US. Because the cost of the equipment is expensive. Similarly for robots, they are cheap robots, vacuum robots. Maybe it's not for Singapore to build. But for expensive robots, like for example, medical robots, each robot cost is very expensive and the profit margin is very high. And if you don't build a lot of units, so why not you build it in Singapore? Because the cost of labor becomes a less critical component. And that's why to say that for a person to be able to develop the next medical robot to be sold in the world, we need someone to really have the feel of this field. Otherwise, he cannot innovate. Robotics is quite strange. If you don't have hands-on to build the mechanical, you don't fine-tune it. Right? The software alone, you don't have the feel of what's the tolerance level. For example, sometimes the motor may vibrate, and that will cause the precision to be out of your requirement. And if you don't have the hands-on, you cannot know that this is one of the problems, and you cannot innovate the good solution. That's why in robotics, you have to learn the whole cycle to appreciate the problem, to generate a solution that meets the market demand, and then you can sell. And that's why you can create the next, hopefully, unicorn. And that's why we feel that for robotics, you'd have to have ability to learn the entire stream, but doesn't necessarily mean that at the end, whole thing will be produced in Singapore. Depend on the category of product. Some category of product, like toy robots, you can make in China. But the very good, expensive robots that can probably, for example, help in surgery, help in rehabilitation, that probably could be still made in Singapore. And hopefully we can have the next unicorn in Singapore selling this product. Maybe your next company, yeah.
That I agree. That I agree. Yes, it's true, no, it's true. Should we build autonomous car in Singapore? No, we should not. It's big, it's expensive, we don't have the supply chain, it's way out of our league. So I'm again advocating that we develop autonomous car here in Singapore, because we develop the technology. All the cars manufacturer is racing to build all the things, and we don't have a platform. All the things that we have, we will buy the car here, we integrate technology inside there. So we build technology on top of a platform. But people engineer things from the ground up. There's no competitive edge for us. But what should we do? We should do the things that are having a niche, like what Wei Yun is saying. Singapore happened to be very good in medical robots, and we are leading the world in many fields. One of my colleagues, Professor Louis Fee, he built a company now on a robot that does surgery. You know, when we do surgery, we open our body, or we call it open surgery, right? We cut open, right? And then we do keyhole surgery, minimal invasive surgery. We punch 3 holes. We do the surgery here with the laparoscope. And then he invented this thing called the no-hole surgery. Know how to go in. Go in from the top or the bottom. All right? You go from the top, you go into your gastric, you punch a hole in your gastric, and then you go in there, the 2 arms come, do the operation, come back out, sew up the stomach, and come back out again. No scar. A surgery, you go open surgery, you stay in hospital for 3 weeks, they become a day surgery. No chance of infection. Right? It's called no-hole surgery, and then we're leading the world. So this company here is built in Singapore. And I have a company as well. I have it in Singapore and Shenzhen as well. I built this robot to cancel the tremor of microsurgery. so the surgeon can have a super stable hand. Right, so all these things will have big needs for in the medical field. Do I need to sell 1 million robots a year? No need. You know the biggest medical robotics company called Intuitive Surgical. They sell the Da Vinci robot. I don't know if you heard of this thing, right? Da Vinci robot. They sell like hundreds units, maybe less than that a year. The market valuation now is 40 plus billion US dollars. It's the size of SIA. Right? If my company has grown to a quarter the size of SIA, wow, I can retire already, right? So why do I bother to sell 10,000 units a year? Imagine there are like 20, 50 companies of this kind in Singapore targeting very niche solution where we produce a very good solution that will lead the world. So that perhaps is the direction that Singapore can go. We find niche with very high value add like what Wei Yun is advocating. That's why I disagree. I say that I think we should build the entire robotic solution, but not for the mass, but for very niche market. So that's my point. All right, so back to this gentleman, which you have another question, yes.
What can we expect in the next 10 or 20 years in this medical robotics?
What can we expect to see?
To see, or
robots.
to enjoy, yes. In medical,
In medical, medical is a big word, right? So we can use robots for surgery. We can use robots for rehabilitation. We can use robots as assistive technology for the aged. So we can use robots for many things. So besides surgery, surgery is the one with the highest quantum gain. So if you list a company, you have company listed in the Nasdaq, right? That's a higher PE ratio. So because it's so hard to get the robots certified, approved by FDA. Once you cross the bar, your patent is very hard for people to cross. That's why the valuation is super high. So, but that is very few, right? So I think what the robot is best used in helping aging population. Rehab, perhaps, assistive. So this will be the next wave of mass adoption. And that's also my research area. I'm very bullish about that. Soon, I hope I can start a company. So my products are ready. So I hope to push out more and more of all these innovations. So, and robots technology, right? So a lot of things, AI, which I think is part of robotics technology because of the cognition part. AI can help in diagnostics. The example that I gave, to link certain genes to cancer, right? So a lot of all this discovery is impossible for human to do the data analytic by yourself. You need all these algorithms that can scan through billions of data points, right? The computer can run for 10 hours before giving you a solution. So what, for human to do is hundreds of years, right? The computer, so what if it's 10 hours to do the data processing, it's fine. So I think that's another area where AI, robotics technology can have a big impact in the medical field.
Okay, maybe I just want to add on point. Sometimes you might also want to look at some other areas that we hope that we can also reduce the needs for nurse to come in.
Yes.
Right. For example, you know that, I'm not sure how many of you are aware that the distance that the nurse need to walk every day is actually quite far. Right? Bringing meals for you, bringing all the towels, and many other things. So this is also one area that potentially can be adopted.
But they need to do 10,000 steps a day, it's okay.
Yeah. Right. But that also brings down to a second point is that perhaps not necessarily all the robots that have to be built in Singapore, then we want to specialize. Right? For example, Apple don't build their phones.
They design.
Right? They design and they build in China. So can someone, because the Singapore government has the lead demand user, there are some demands out there, and somebody can design a good robot, test it out in Singapore until it's proven. Then you let other countries build it. You just control the brain. And that's why we hope that we can encourage people to learn robotics, because then they have the whole field of developing a robot that meets the market need. Then we don't have to worry about the production. Let somebody produce, but then you control the technology, just like Apple did. Right? Hopefully that will encourage all of you to encourage your kids to study robotics.
Study engineering first. Very poor. We don't make a lot of money, so people don't come to us to study. Any more questions? Maybe I'll take 2 more questions before we end the day.
Okay, I have. I'm just thinking aloud. you see, actually, I always feel that engineering is very important, and engineers are very much undervalued.
Yes.
Even the very chair and things like that you sit is engineering. So in spite of robotic, I still think that engineering still comes in because you need to build the robots. And engineering will never be outdated because in anything you do, everything you consider, engineering must be the first part of it. And even between robots, there are nice robots, good looking and things like that. So engineering will still be one aspect. The other thing is, I also feel that robotic, much as is very important, I feel that it's just a subfield of automation. The broader field should be automation itself. And I also think that with AI, all these things, just now you mentioned that, our level, we will not be, the AI will not, the robots will not steal our job. But then how many of us can actually reach that level? And also how many will be in that kind of very high proficiency field? So what does the rest do? And also for the technology to catch up, then I feel that the people and the country's institution must come first. So when people say that they are obsolete and things like that, it's not the people, it's how fast the nation moves. So I also think that the people policymaker must make a great choice or correct choice. Your comments.
Right. I can understand the anxiety, which is what I was talking just now. One way, of course, to future-proof, right, is to join the people that build the robots, right? So then you become a white-collar job. That is possible when you were to advise your children. But for the current generation, which is already trained, it's very difficult to do so. You have inertia, you are hard to be retrained, so you feel the anxiety. But that's why I say, right, so there are the last two bullets in the thing was that, number one, you need to be able to be retrained. If you cannot be retrained, never mind, you need to be able to work alongside a robot. Because not all the jobs will be replaced, but then I think a lot of jobs will allow you to work alongside a robot. So the idea of cobot is that you put a robot in the line of human production, of human manufactured goods. So some of the things are best done by robots. Some of the things are not easily done by robots. So the things that require very dexterous manipulation. I'll give you an example. So Singapore is a big logistic hub. So they repackage a lot of things here. So they ship in the detergent from Thailand, then they ship in the toy from China, and then the instruction booklet, the instruction paper is printed in Malaysia. So they ship in containers here, and then we repackage them into two pack of detergent, give you a toy. Repackage the thing into a pack, shrink wrap, and then ship out into the region. So we do a lot of repackaging here in Singapore. That is a process that's very hard to be done by automation because of the high variability. Today is 2 detergent plus 1 toy. Tomorrow is 2 boxes of cereal with some other thing. So that is very difficult. So with that, right, what they do is that robot work alongside with me. So there are 3 workers there to do the highly mixed thing, and then a robot to do the printing or whatever, or to do the string wrapping. So that, right, the person, when robot comes along, the person need to be adapted to learn how to work alongside with robot. So that is a must. It's a must. But then if you can elevate yourself to that level, to adapt yourself to work with robot, then I think to a certain extent, right, most of us should be fine. Right? So because I know that not all can build robot at this age. I mean, if you are listening here, right, unless you are kids, right, you have missed the boat already. Yeah, it's true, it's true. So for the next generation, that's what you can choose for your children. Okay?
Maybe just to also address your point about the importance of engineering. Yes, fundamentally, robotics, the foundation of robotics comes from engineering, right? Both the electrical, mechanical, the AI part. All these are required in order for a person to be trained in engineering, in robotics.
Engineers in Singapore are paid a lot lower than those in Europe and America. That's true. Yeah, but why don't we do so? So the government keep pushing us to say that you must increase the intake of, you must train more engineers, right? So every year when we train a batch of engineers, a lot of them flow out of engineering field. They become sales, they do something else, right? So we say that a big leakage. So the EDB way of solving this thing is at university, right? You intake even more so that you can cater for the leakages. Then in the end, right, we take in more students. So we cut off at CCC. Next year cannot cut off at CCD. Cut off cannot CDE. All right? To the point that those students that you bring in, and then in the end they don't do well, then you create even more leakages. No problem. We intake even more so that we can afford for the leakages. So then government keep coming to us to say that why can't we keep these people? Why can't we train more engineers and to make them serve in this field? So the answer to them is that you pay engineers more. Right? Government take the lead, right? You pay engineers peanut, and that's why people are moving out to other fields because everybody make more money than engineers. And then why engineers not being done well? Everybody want to be manager. Why? Because manager control the engineers that are outsourced in Philippines. That happened to our MRT system. Right? Why we have no good engineers at the 40, 50 level, chief engineer level to solve this thing? Because in the 90s, we make the decision that engineering not important. Let's outsource to other country. Let's all be manager. Manager control engineers, and everybody wants to be manager. Nobody wants to be engineer. Look at what happened to MRT system now. Right? So we need engineering capability, and that's really real. So unless we reboot and restart again to make engineering good again, we are having a big problem. Government has started. 2 years ago, they raised the pay of government job, engineering job, starting pay 4,000 now. So that created a big wave in the industry. Everybody say government sabo us. Now everybody must raise the price of the engineers, right? So I think it's a good move in the right direction. So if not right, we're always staying at that level. Who wants to be engineers? Those CCD, CDE that cannot make it, all come to do engineering in the end, cannot do anything. They leak out again. Right? We have to do something. Engineering is really important, of course. Let me take one last question before I end the day. That's one. I take you as well. Okay.
Yeah, Prof. Ang, you had earlier quoted Elon Musk. But besides Elon Musk, there's also the late Professor Stephen Hawking, who were fears of AI being a threat to mankind. So is his fear valid? And also, I think it's related to this. You have presented to us that AI is still at a very rudimentary stage. But years from now, with the advances of AI, and to me as a layman, AI seems to be codes, algorithms, and so on. Is it possible for AI to attain self-awareness or self-realization?
Yes, I think in years to come, maybe, but I don't know which year would that be. So I think there's a recent example, there's a fear, robot creating new language. So robot, after it optimized the process, right, robot to robot communication, it generated its own language that human cannot understand. So this optimized the thing, and that is being widely reported in the newspaper. So you see, machine has gained intelligence to create its own language that human cannot understand already. So we are very fearful of this thing happening. But in fact, you look through this thing, right, people don't know this thing, there's no big deal, no big deal. So when we generate machine code, right, there's a lot of redundancies. Because it's, we say now everything is 64-bit, right? It's every word, right? Every command is 64-bit long. But you do not need 64-bit for every command. So some of the thing, right, after the 34-bit, right, everything else is junk, no need to use. So it can be whatever. So after some time, robot thinks that, right, the last 20 bits are not important. So it truncate out. Then it become more efficient. So when that thing happened, right, then the language, they drop a D here, drop a C there, it become a new language that only they can understand, that we can't understand. But there's really no big deal because they just drop off the thing that is not useful and then communicate in that. You know the machine language, right, it's no big deal, but people make a big hoo-ha that this is very dangerous. You see, robot is getting so smart that they create their own language. There's a human's doomsday. No, it's not true. No, it's really not true. So it all depends on what you design robot to be. At a certain level of creativity, compassionate, all this level of what a wink mean to us, all these things, right, I don't think there's ever we can program. Remember what I said, right? Decision making, right, still in the programmer. I don't think we can ever program all the scenarios. Every person that experience this thing, a wink in this context mean different thing. In that context mean different thing. That's impossible for the robot to take all this thing. Personal experience, everything is impossible. So would the day come that this robot become a human and then become so smart? Perhaps it's getting closer to human capability. But really, as what Rodney Brooks said, if you read his 6 reasons why robot is not going to be taking over the world, right? For people that build robots, understand that the technology, right? Unless there's a drastic different way of building robots, which we do not know yet, for the current way of building robot, right? I really don't see the day coming so soon. No? Would it happen one day? I can't say no, right? Probability, right? Probability is low, but can I say 0? Maybe not, lah. I do not know, but I don't think that it will be in our lifetime. Yeah. So maybe one last question before I end the day.
Hello.
Yes, we can hear
this
you.
question is directed to the 3 speakers. So I'm just wondering, what do you suggest to the younger generation to do and work on so that we can be capable to lead the nation in terms of engineering?
What to focus on?
What do you suggest to the younger generation to do and work on so that we can be capable to lead the nation in terms of engineering?
What engineering? He say. Yeah. Say again.
So I think the question is
what should they learn? What should they be focusing on?
Yep.
Younger generation.
Yeah. For the younger generation, okay, the fundamental important part is that the desire to learn new things, because honestly, we cannot foresee. If you look at the whole mechanism, right, the areas has changed over your life. I mean, for example, 30 years ago, 40 years ago, internet was not there, right? But now today, internet is everywhere. So what makes a person able to learn quickly, right? So that adaptability is important. So basically, a very good foundation, right, in mathematics, in language, in the logical thinkings, right? All this build up allows a person to acquire a new skill easily. I think that's very, very important. Then the secondly is the desire to learn. Right? If a person do not have the desire to learn, then he'll be unskilled quite fast, right? With the fast evolution of technology. So I don't have a good answer to that, but specific on engineering, you need to have good mathematics, physics background. If you are in material, then chemical is important. So some foundation mathematics, some foundation sciences are important. And lastly, basically, once you come to the university, choose the basic engineering first when you go in, right? And subsequently branch out, specialize in certain areas. And one of those areas that specialize in is robotics. In robotics also there are a few other topics. So it depends on which level, but I think fundamentally is the desire to learn that's important.
You want to add?
I do not have a straight answer as well. I think what I agree with Dr. Yau's answer. Basically, engineering, important is really when a person go into engineering, what make him pick that particular discipline, right? For me personally, why I pick engineering, primarily I like new things. Second thing, because I get excited, I get fun out of making things work, right? So that is one of the reasons there are very few of us at our age that are still doing hardcore engineering work. So if you are able to have that passion, I would say that it doesn't matter which particular engineering that you enter. And definitely engineering, as it goes, there will be some of the discipline at a certain point of time that seems to be more useful. But one of the other bottleneck which the whole world is definitely facing will be material. Material is definitely one of the area also getting more and more challenged. If you look at IC chips, getting smaller and smaller. So the next breakthrough you can do is really on the material, right? So things like this. The other way that you want to really keen to look at what are the potential interesting area will be doing so-called take a quick snapshot of what are the IP generated in which area. So if you want to help your children, then look at what are the IP generated in which area, especially for the big organization like Apple, Samsung, and all this. That will give you a very good indication what are the technology is up and coming. There's just some of the advice I can give.
My take is this. a balanced approach to education is very important. We cannot have the whole nation to be engineers, of course. So it has to be a balanced approach between hard skills and soft skills. We don't need everybody to be engineers, but we need everybody to understand how AI and all these hard skills. So that is the balanced approach to engineering is what we always call the T-shaped educational system, right? So you do things that are broad-based, you specialize in one field, you go deep into one field. Whatever that depth is, it can be soft, it can be accountancy, I don't care, accountancy, business, it can be engineering, as long as you acquire the depth there, but the breadth must be there. Gone are the days when we were trained as engineers, we do nothing but engineers. So they always say that, right, NTU graduate can only do, cannot talk. Engineers cannot talk, so we only study engineering, very flat, right? But now we train our engineers differently, right? Engineers are more articulated, we have a more world view. So the soft skills are as important as the hard skills. So for people doing soft study, soft subjects like mathematics, like social studies, the social sciences, I think being able to understand and know some of the hard skills are also important. That is a T-shaped thing, the flat part, and then you go deeper on one of the verticals. So I think that model is robust for any field. So fortunately, Singapore is going towards that direction as well. So we are designing our tertiary education to be a T-shaped model now. So 20-25% of engineering courses has to be broad-based. So you learn languages, you learn even dance or whatever, all right, give you the broad base. Okay, so hopefully that answers your question. So thanks very much. It's quite late already. Luckily today no football. Yeah. Okay, so thank you very much.
Yeah, I think we have to thank our speakers one more time, our panelists. Of course, you yourself can ask lots of questions. And we want to give our guests a small total appreciation. And of course, for those who are taking buses, please proceed to the bus station now, and they are waiting for you.
Thank you. Good night. Good night, everybody.
Thank you. John, there you go.
Okay, 1, 2, and 3.
Can't wait.
Thank you.
Thanks.
Okay, thanks a lot.
Sure. Thank you.